Okay, dear learners, my name is Dr. Rajeev Kumar Mishra and I am working as an associate professor in one of the AKTU affiliated colleges. In this module, we are going to discuss the evolution of solar drying systems. You know, the solar drying is one of the very important concept in drying technology, especially for the food and agriculture residues. So for this, I have divided this presentation in the following content. Like first, I'll give you the brief introduction about the sun drying systems. Then we'll discuss about the open air drying, firewood, fuel drying, electrical drying, and most important, the solar drying. How these solar drying systems have been evolved, and the various merits and demerits of different drying methodologies will also be discussed in this module. Open sun drying has several demerits like spoilage of product due to adverse climatic conditions like rain, wind, moist and dust. Loss of material due to birds and animals, deterioration of the material by decomposition, insects and fungal growth. Also, the open sun drying process is highly labor intensive because we need laborers all the time to control the drying in the open sun drying. It is time consuming and requires large area because we need to spread our crop, our agriculture residues in a large area. The open air drying has now been largely replaced by mechanized dryers, and these mechanized dryers are speeding the drying process. This process is highly energy intensive and expensive, which ultimately increases product cost. Mechanized dryers use boilers or electric heaters to heat incoming air, and fans are used to force it through at a high rate. So mechanized drying is faster than open air drying, uses much less space and usually gives a better quality product. But the major demerit of these mechanized dryers are the cost of expensive equipments and substantial amount of fuel and electricity to operate these mechanized dryers. The solar drying is the best alternative as a solution of all the drawbacks of natural drying and artificial mechanized dryings. Applications of solar energy in food processing industry is mainly limited to drying operations. Solar vegetable fruit dryers operates below 55 degrees Celsius are used for this purpose. In recent years, many solar gadgets have been developed for a variety of applications. Because of excellent, consistent quality, materials processed in these units gadgets can enjoy great market potential. Extremely low capital cost investment in the solar dryers technology makes it financially possible. Based on the method of heating air, there are 4 common drying methods or techniques that are utilized for drying purposes. One is the open air drying, which has already been discussed in detail in the previous module. It is the old-fashioned and simple drying technology used by urban and rural areas. Here in these 3 diagrams, we have seen how this open air drying takes place. The product to be dried are spread on a sheet. Different modes are there, like we can spread this food or agriculture residues on mat, or we can use some pavements for drying. The direct on the soil and in open air and exposed directly to the sun for drying. Yes, obviously some advantages and disadvantages will always be there because any technology is 100% perfect. Second is the firewood and fuel drying. The ambient air may be heated by burning fuel wood or fuel to contain the required heat for drying. Here, the drying could be continuous during day and night. Then the electric dryers, which has been seen in this diagram, the ambient air may be heated by electricity. Electricity or coils are there, and in this we can use some trays for drying, and on this tray we just spread our product and the air will be heated by electricity. The drying could be continuous during day and night as long as the electricity is available. Then third and very important drying which we are going to discuss in this particular module is the solar drying. The process of solar drying differs from mentioned 3 processes by the way of heating of air by the solar radiation. Here we will not use any mechanized way of heating like electric heaters or fuel by burning coal. We use the solar energy for heating of the air, and heated air could be circulated naturally by buoyancy. Is a very known concept and phenomena, buoyancy, that the hot air always goes up. The heated air could be circulated naturally or by ventilator powered by PV array or electricity. We use some photovoltaic modules to supply the electricity to run the fan, and with this fan the heat air can be circulated. In these two diagrams we have tried to explain the solar drying. In first one, you see cabinet type of dryer where the food to be dried placed inside that cabinet. The sunlight falls on the glazed surface and the sun ray transmitted through this glass and it will be absorbed by the food. Then the temperature of the food increases and evaporation takes place from the surface of the food, and cold air will enter from the bottom of this cabinet, and finally the moisture from the food will be taken away by this cold air and the hot air will go out from the top of this cabinet. Insulated coating walls will be there so that the side losses could be minimized. In the second diagram, this is the indirect type of solar dryers where sun radiation falling on the glass will be transmitted and it will be absorbed by the bottom blackened surface. The cold air will enter from this bottom and the blackened surface will start transferring its heat to the air. The air gets heated and this hot air will go up, and in the drying chamber where crop is placed, it will enter from the bottom of the crop. The temperature of the crop increases and moisture will go out with the help of the air vents. Then the classification of solar dryers. Drying by using solar energy can be broadly classified as open sun drying and controlled drying, because we have already discussed in detail the open sun drying where we are not having any control on the drying. It all depends on the availability of sun and all other parameters. So we have not any control on this drying. And another is the controlled drying. In this table, the solar dryers has been classified in two broad categories: open sun dryer and controlled dryer. The controlled dryers may be of active mode or passive mode. Passive mode means the flow of the air will be through the natural convection, and in active mode the forced convection will be there. This passive mode, that is the dryers with natural convection, is further can be divided as cabinet dryer and greenhouse dryer, and the active mode dryers, the very important dryer is the mixed mode dryer and integral type dryer. We'll discuss all these dryers one by one. Open sun drying we have already discussed in detail. The open sun drying products are spread in the open space in thin layer and exposed directly to the sun. Though this process is economical but have some disadvantages, like open sun drying requires presence of somebody at the site throughout the drying period so that the products could be protected from birds, animals and adverse weather conditions. The resulting dried products are not of high quality because of dust and other sediments present in the atmosphere, etc. The products are usually unhygienic. Sun drying tends to be labor intensive and has limited capacity. Temperature control is also difficult in this method and product can easily be overheated, causing cracked grains which leads to low milling quality. It is also not possible for the open sun drying at night and in the rainy season. Above problems can be resolved by using controlled solar drying techniques, and we will discuss this controlled solar drying like passive mode dryers, active mode dryers one by one. The passive solar dryers, which uses the natural convection. In passive solar dryers, air is heated and circulated naturally by the buoyancy or as a result of wind pressure or in combination of both. One very important type of passive solar dryer is the solar cabinet dryer, which are being used especially by the farmers. The solar cabinet dryers mainly consist of a drying cabinet. One side of the cabinet is glazed, which can easily be seen here in this diagram, to let admit solar radiation in, which is converted into low grade thermal heat, raising the temperature of the inside air, the drying chamber and the material to be dried. Usually the solar radiation falls directly on the material to be dried. The moisture evaporated by solar heat is removed by the air circulation. This is accomplished either by designing to encourage natural convective air flow or by forcing circulation with fans or blowers. We can use some PV modules to run these fans and blowers. The material to be dried is placed in shallow layer on tray inside the drying cabinet. Proper air vents are provided for displacement of most hot air. A simple box type of dryer could be easily constructed. It's not difficult. It is very simple to construct the cabinet dryers by locally available materials. A simple box type dryer could be easily constructed by farmers or villagers. It consists of wire mesh trays fitted in wooden framework and covered by a clean plastic sheet. Such a dryer is usually called cabinet dryer. A typical solar cabinet dryer of 10 square meter surface area could dry about 20 to 50 kg of produce about 3 to 4 days if adequate sunshine is available. Then second passive solar dryer is the solar greenhouse dryer. Solar greenhouse dryer, it has been presented here in these two diagrams. Solar greenhouse dryers are characterized by having extensive glazing on their south facing side, because more sun radiation is available from the south side, while the other sides are well insulated. Inside the closed area, some means are provided to store the daytime excess heat. Vents are strategically sized and positioned to control the airflow. A well-designed greenhouse dryer permits a greater degree of control over the drying process than the solar cabinet dryers, and should be used where relatively large quality and quantity of products to be dried. And the very important active solar dryer in the control dryer is the mixed mode dryers. In the dryers, the heated air from the separate solar collector is passed through the grain bed, and at the same time the drying cabinet also absorbs the solar energy directly through the transparent wall or the roof. Here we can see this design. A separate solar collector is there, so the sun radiation falling on this transparent cover will transmit to the cover, absorbed by the base of this collector, and the air gets heated. This air will blow from the bottom of the plenum chamber, and your food or agriculture products gets dried. And also at the same time, the solar radiation falling on the transparent roof will also transmit it. So it means that the drying of the food in this mixed mode dryer takes place in both mode, direct and indirect. Direct means direct sun radiation falling on the top of the crop or food from this transparent roof, and also at the same time the hot air collected from this solar collector will flow from the bottom. Then the use of solar dryers. Depending on the cost and temperatures, we have different types of solar dryers. The low cost solar dryers, which used for the small scale farmers and which can be used for the all type of products. Solar dryers PV powered. If you require some electricity for the forced convection, then we can use this solar PV powered solar dryers, and which is being used mainly by the medium scale farmers, and which is also used for the all type of products. And then solar dryer AC powered in the mixed mode dryers, which has been used on this industrial scale and mainly for the industrial products, especially for the medical and pharmaceutical products. Then we can compare these four types of drying technologies like open air drying, firewood fuel drying, and electrical drying and solar drying on the basis of their merits and demerits. Then in open air drying, we see no investment is required and no fuel is required, whereas in firewood or fuel drying, quicker than the open sun drying. Then electrical drying, the drying is quicker than both the above two drying techniques, firewood and open air drying. And the solar drying is the affordable, easy to maintain and operate, does not require a specialized manpower, well controlled and quicker drying. The products are well protected during the drying process, can be produced locally and from local available materials. And the most important thing is that the sun drying is environmental friendly, because we use green source sun as the energy source to heat up the air, and hence it's very environmental friendly. But with all these merits, some demerits are also associated with this solar drying. And the important demerits of this solar drying is that requires introduction to the technology, because open sun drying is okay, but for solar drying we use, especially for the control drying technology, we require introduction to the technology. The dryer should be operated properly to have a good quality of the dry products. Components of solar drying system. The fruits and vegetable products can be dried by various ways. Air is widely used as the drying medium because of many merits like its availability and convenience in use. The principal components of solar drying systems are represented here in the schematic diagram. We can see the solar air collector, a part, the air handling unit, and the drying unit. These three are the important components of any solar drying system. The solar air collector, also called as the solar air heaters, are used to heat the ambient air. There exist several designs of the solar air dryers. Air handling units. The air handling unit consists of a blower and a suitable duct work. The air handling unit takes heated air from the solar collectors and send it to the drying unit. And the drying unit takes place in the drying chamber or drying unit, where heated air extracts the moisture from the product to be dried. Many designs are available in the market. So here we see that the solar radiation falls on the solar collector, the air gets heated, and in air handling unit, the hot air will go to the drying chamber where actual food is there which need to be dried, and the hot air will extract the moisture from the food product placed in the drying chamber, and the moisture carries away the air inside your crop, and we left with the dried fruit product. The air handling unit should into consideration the fact that more air is required to transfer heat to the products to evaporate the moisture present than is needed to transport the vapor from the drying unit. It's a very important concept here. Usually 5 to 7 times as much air is required to heat the products and to carry away the moisture. The heating of cabinet air can be done by variety of ways, by making use of different kinds of energy resources such as electricity in electric heaters, oil in furnaces to produce steam, gas in boilers to produce steam, solar energy in solar air heaters, and biomass, wood and agro waste in gasifiers. Gasifiers are also being used to heat up the air. So these are the air heating unit, and we can use these various units, but in this section we are majorly focusing on the solar air heaters, in which the air is being heated with the solar energy. The last two options are still not popular because of many diverse factors, that is solar energy and biomass. In the present world of energy crisis, the availability of commercial energy, that is electricity, gas, coal and oil, is going to be continuously depleting and becoming costlier. Therefore, the last two options have to be considered seriously, that is the solar energy and the biomass, which are also the renewable energy resources. Making use of solar and biomass for drying may be termed as energy substitutions, where these renewable energies are substituted for the commercial energy used in conventional drying. A dehydrator or drying unit should be able to control the temperature, air velocity and relative humidity. So some special designs are there so that your drying unit can control the temperature, air velocity and the relative humidity. The dryers commonly uses tunnel, belt, bin, column, rotary and cabinet types. So in this section we have discussed how this solar drying system has been evolved, like open sun drying, firewood fuel drying, electrical drying. We have discussed all these drying evolutions and in terms of their merits and demerits. Okay, thank you very much.